Title: Quantum Cafe. What's in a black hole? Deadpool's Deluxe Tour. Cast: Deadpool, Einstein, Dr. J.L. Schrödinger's cat. The Quantum Cafe stage. Starfield wallpaper. A chalkboard titled How to Bake a Black Hole and Keep It Spicy. Deadpool walks in wearing a cosmic apron and holding a singularity-shaped cake mold. Deadpool, ladies, gents, photons, and fermions, welcome back to the Quantum Cafe. I'm Deadpool, your slightly unstable tour guide to the cosmic freak show we call reality. Today's dish: black holes Millar style. Lights dim, soft piano plays, a glowing orb appears center stage, the Chrissy singularity. Deadpool, we start here, not with a bang, but with a stillness. The Chrissy singularity, absolute zero, no space, no time, just pure coherence, no blips, no particles, just potential. Then it shatters, and what does the universe spit out first? He tosses glowing marbles across the stage, primordial supermassive black holes, and a truckload of hydrogen. Its structure and simplicity launched outward into the newborn memory fabric. Einstein, arms crossed. This sounds suspiciously non-Euclidean. Oh, it gets worse. Al, see, space isn't a thing you travel through. It's something you write, one blip at a time. The fabric is the ledger. Every particle that vanishes etches time. Every appearance creates space. Now enter the black hole. In the standard model, it's a region of space-time so curved, not even light can escape. Singular core, infinite density. Game over. But in the Millar Cosmological Model, it's something deeper, something more memory-heavy. Dr. JL enters, carrying a scroll of glowing equations like a seductive Torah. In MCM, a black hole isn't a mystery, it's a memory pressure zone. The place where quantum blip density gets so high, the memory fabric collapses inward. At the center, not a dot, not a paradox, a reformed Chrissy core. Boom, the original still point rebooted. It doesn't explode, it absorbs. All those stuck points, the antimatter anchors of every Arnie, get pulled in and tensioned tighter than Schrödinger's cat's nerves on vet day. The cat walks in, sipping a martini from both alive and dead cups. Shh, cat, I heard that. And yes, it's tense in there. But how do you explain time slowing near a black hole? Simple. When the rate of quantum disappearances, the blips, increases, more ticks of time get written per second. The memory fabric has to work harder. So from the outside, time looks like it's crawling. Think of it like trying to write a novel while skydiving. The faster you fall, the harder it is to keep your sentences straight. He draws a circle around a black sphere. That outer edge, the event horizon. In MCM, it's not a wall, it's a threshold of memory saturation. Past this point, the memory fabric is so dense with entanglement and tension that photons can't find a clean path out. They drown in blip traffic. Einstein, intrigued despite himself, and what lies on the other side? Now we're talking multiverse mechanics. Every time a Chrissy core forms, it's not just a hole, it's a bridge. A place where the memory fabric pulls taut enough to graze adjacent dimensions. In theory, what collapses here may be written elsewhere. Information isn't lost, it's redirected. Just in a frequency you can't decode. Schrödinger's cat, it's like falling into a verse of reality you weren't meant to read. Unless you're part of the rhyme. So, yeah, black holes in the standard model, useful, powerful. But in the Millar model, they're recording nodes, anchors to the first moment of coherence. They hold tension, store memory, and maybe birth reality on the far side. He puts down the chalk, soft glow fades. And the best part? It's all the same physics until you reach the middle. Want to build the next scene around what happens after black hole death? Maybe tie it into rebirth, white holes, or consciousness leakage across the field?